Okay, so in this case, again, start with our X-Intercepts. Let's see, so it's in factored form. That's actually really nice in that when I set that up, I can see real quick that it's going to be at x equals 2 and 4. It's a little deceptive because we have another concept coming in. So I reserve the right to come back to my X-Intercepts. But for right now, I'm going to say that it's at negative 2, 0, and 4, 0. And the Y-intercepts, same deal. Let's see. Well, let's see. Let's actually jump down to, let's do domain real quick. So the domain, I can see that I'm going to kick out a negative 2 and a negative 3. So negative infinity up till negative 3 union, negative 3 to negative 2, negative 2 out to infinity. Do you see the whole? See how that part divides out? So that really means that at negative 2 comma something, there's actually a hole there, which is why I said I'm going to come back and reevaluate this. Holes really mess up the order of things. So to find the hole, we want to evaluate that x value in the reduced form. So f of negative 2 equals negative 2 minus 4 over negative 2 plus 3. So we end up with negative 6 over 1, so negative 6. So negative 2 comma negative 6 is where my hole is at. It means we can come back and look at that y-intercept again. So the y-intercept, now that I have the reduced equation of x minus 4 over x plus 3, I can just find that, plug 0 into the reduced. So 0 minus 4 over 0 plus 3. So we get negative 4/3. Ooh, we get something new this time. So 0 comma negative 4/3 for our y-intercept, yay. Horizontal asymptote. Okay, this is the reduced form, top heavy, bottom heavy are same. This is the same case. So I'm going to look at a ratio of leading coefficients. So out front, you can imagine we have little 1s there. So it's y equals 1 over 1, which means our HA is y equals 1. Point crossing that. Okay, so we're going to take the HA and set it equal to this reduced form, so x minus 4 over x plus 3. And we're going to multiply both sides by x plus 3. So distribute that, and I get x plus 3 equals x minus 4. Now, hopefully you'll catch that when I try to get the x's together, I get something that just isn't true. So it does not cross the HA. Okay, so back to our process for graphing. Let's go to any asymptotes, any points, and then I'll go look at the table. All right, asymptotes. We have, oh, I never did find that. Okay, so vertical asymptote would be x equals, in the denominator here it's x plus 3, so x equals negative 3 would be the VA. Okay, sorry about that. All right, so VA, so negative 3, so put a vertical asymptote there. Okay, HA of 1, so put that there. Have it cross that 1. I know at 4, 0, it's going to cross the x-axis. And at 0, negative 4/3. So negative 4/3, that's a good estimate right there. Wow, I can already kind of see what's going to happen here. Okay, so on this side, I can see it's got to hug the asymptote that way. I already know that it does not cross the HA, so it's got to continue to go down. On this side right here, so this side, I'm waving my pen like you guys can see me wave my pen. So on the left side of the graph, though, kind of think about it. It's either got to be a below or above, right? Well, can it be below the asymptote? And the answer is no, because we already know where it did cross. So that means it's got to be above, so it's got to hug on that side. So in this case, I didn't really need a table. I kind of had enough information that I could deduce what the graph was going to do. All right, next one. Let's go through the same process. Let's take a look at factored form real quick, since that seems to save us a lot of time if we have it. So x plus 1, x minus 1, all over x minus 2. Okay, so I can see that nothing divides out. X-intercepts, in factored form, I can see that if I set the factors equal to 0 and solve, I can very quickly get those points. So that means it crosses at 1, 0 and negative 1, 0. Y-intercept, so f is 0. I'm going to plug that into the original one since factored form doesn't really help evaluate that, but hopefully you'll see some shortcuts here. So 0 squared minus 1, 0 minus 2, so I get positive 1/2. Okay, so 0 comma a half is where it crosses. Domain, looking at the denominator, I'm going to kick out 2. So I'll write that 2 out to infinity. Consequently, that's our vertical asymptote is x equals 2. There is no hole. Okay, and here's that moment of truth. I mentioned this case earlier, and it'll come up, and here's where it's going to come up. This is a top-heavy rational, so it does not, there is no HA, but there is an oblique asymptote. And so this is where we'll look at what that actually does to your graph when an oblique asymptote shows up. Okay. So because there's no HA, that means there's no, we don't have to worry about it crossing the HA. And if you recall, because it's top heavy, that's where synthetic division is going to come in. So I have x squared minus 1 over x minus 2, and I want to divide that out. So I'm going to make a list of all my, highest exponents squared. So make a list of my coefficients. So that'd be 1, 0, and negative 1. And I'm going to synthetically divide in, not minus 2, but positive 2. Remember, factored form, we want opposite of that. And then I'll drop. So drop the 1, multiply, combine like terms, multiply, and I get 3 for that. Okay, so when I divided, I got x plus 2 plus 3 over x minus 2. So our oblique asymptote then is the equation y equals x plus 2. Okay, so we'll talk about how that's going to work in the graph in a second, but remember your process is asymptotes, points, and if needed be table. Okay, so let's come up here and our asymptote being x equals 2. So we'll plot those points, plot that asymptote there. Okay, and our oblique is the equation y equals x plus 2. Well, we've actually practiced graphing linear equations recently. So that says that I'm going to cross the y-axis at 2 and go up 1 and over 1 for my slope. So cross it at 2, up 1 over 1, up 1 over 1, up 1 over 1. Okay, down 1, down 1, down 1. So we can kind of see this diagonal line that it's going to intersect at. Okay. Now let's go to our points. I can see points at, I can see points at 1, 0, so right there, and at negative 1, 0, and at 0 and a half, okay, and that's about it. Okay, so then I come back in, and I'm going to do some hugging. So I can see on the left side that it's got to have this shape to it. It's got to hug down. It's going to follow that down there. And then the question is on The right side, is it going to curve down there or is it going to curve up there? So is it going to be the bottom half or the top half? Well, if you think about it logically, we solved for where it crossed the x-axis, and this part of our graph did not show up. So it can't be down, it's got to be above. So when we sketch that in, then we're just going to have it hug the asymptotes that way. And so that's how that particular type of graph would work. Okay, so our last example, let's jump to factored form. So we have x minus 1. Let's see, so that would be x and x. Let's say 3 and 2. So minus 3 plus 2. Okay, and then from here, we'll set the numerator equal to 0 and solve. So we get a 1 out of that. So it crosses the x-axis at 1, 0. Y-intercept, we'll evaluate that at 0. So 0 minus 1, 0 squared minus 0 minus 6. So that gives me positive 1, 6. So 0, 1, 6 is where it crosses that. Domain, I can see that I don't want x to be negative 2 and positive 3. So that's what I will kick out of the domain. Vertical asymptotes are consequently the numbers we kicked out. There are no holes, since nothing divided out here. And let's see, horizontal asymptote. It is a bottom-heavy rational, so that means our HA is y equals 0. And so then I want to set that thing equal to 0 and solve. So 0 equals x minus 1 over x squared minus x minus 6. I'm going to multiply both sides by that denominator, which is going to make this a lot easier equation to solve. So I get 0 equals x minus 1. So that means x equals 1. And we actually know the ordered pair for this, since that's actually our x-intercept is that. So it crosses at 1, 0. Okay, so order of ops. We'll start with our asymptotes. We'll go to any points that we happen to know about. And then if need be, we'll look at our table and see what we get. Alright, so our asymptotes are at negative 2. Then we have another one at 3. And I have an HA at 0. Okay. I got a couple of ordered pairs to plot. I got 1, 0, so it does cross. We already knew that. And I got 0 and 1, 6, so it goes up there. And let's see, so part of that I can see. So I know it's got to go up again because I know it doesn't cross, right? The next question then is, what's going on at, say, past negative 2, like negative 6? So if I knew if it was above or below, then I could fill that in. So we'll test that point. I used up all my space there. So negative 6. So we get negative 6 minus 1 over negative. So actually, factored form. It's nice. Let me go back. I apologize for that. So negative 6 minus 1 over negative 6 plus 2 and negative 6 minus 3. Well, if all I care about is positives and negatives, the negative 6 minus 1, that's a negative result. And down here I get negative 6 plus 2, that's negative, so I get a positive. So overall I got a negative number of some type. which tells me that the y values have to be down below the asymptote. Let's see. I don't know if it's going to go up or go down past 1. So let's just use 2. Let's just use 2 then and see what happens. So 2 minus 1 over 2 plus 2 times 2 minus 3. And let's see, up top I get a positive, that's negative. So with 2 positives and a negative, I get a negative result, which tells me it's got to curve down. So that part wasn't right. And then the very last component is, we'll kind of test at 6 and see if it's above or below, but I kind of get a sense as to what I think is going to happen here. So evaluating that in the factored form, we get 6 minus 1, 6 plus 2 times 6 minus 3. And let's see, I get positive up top, that's positive, so everywhere is positive, which tells me all the y values have to be above the asymptote. So I'll shade it in that direction.